I get to welcome you all to this event today, our celebration of Edward Tolman. Really, I was saying that there were two inspirations here. One was that we heard, of course, that Berkeley was going to be celebrating the 50 years of the free speech movement. And we certainly recognized that we had a stake in this. And so I conferred with Lucia and thought, we really should do something here, building on Tolman sort of being the seed kernel for kicking off Berkeley's free speech movement. And the second was Shelley Zedek coming by my office every 2 months to harass me that our students don't have a good sense of the history of our department, and what are we going to do to address this? And he's come by every 2 months, and I'd say, okay, we're thinking about it, and then once we had this idea, I could say to him each time, well, look at what we have going on here. We have a full-day symposium. But what I really want to do is I really want to thank our faculty lecture committee. That's chaired by Lucia, Rona Weinstein's on it, Dacker Keltner, and Sonia Bishop, for actually taking what was a simple idea. Let's have one lecture to celebrate Tolman's legacy and setting the stage for the free speech movement and turning it into this wonderful full-day symposium to celebrate both the man and the maze. That is, talk about his political impact in the morning, and then this afternoon we'll resume and hear about his impact on science. So with that, I'll turn it over to Lucia, but we're really grateful for the work of the committee in putting this together.
Thanks, Rich. Rich has been absolutely the person who started this whole ball rolling, and it's very glad that this all happened, and thanks to the speakers very much for showing up for this. So I also want to thank our sponsors. This is actually sponsored by, in addition to Department of Psychology, Helen Wills Neuroscience Institute, and on the same page, the 50th anniversary of the Free Speech Movement Fund also is contributing, as well as the Pater Sather Center at UC, and finally the Minerva Foundation. So I want to start, the reason I organized this meeting was because it's totally selfishly, because I wanted to hear these talks. And the reason I wanted to hear these talks is because Tolman has always been a great hero of mine. And I think this comes from my own personal history as an animal behaviorist. When I was an undergraduate studying animal behavior at Cornell, Gustav Kramer was the god of animal behavior because he had worked out that animals have a sun compass, that they can use the sun as a directional cue. He had worked out, basically founded the field of the study of animal orientation by his studies of the homing pigeon. And in fact, the big question that I was kind of intellectually imprinted on is, how do you navigate? How can the pigeon do this? How can you release a pigeon 300 miles away and the pigeon can beeline back to its loft, covering ground it had never traversed before? So I think when I came to Berkeley and set up my first faculty office in Tolman Hall, it was kind of inevitable that I was going to be drawn to the cognitive map. Kramer and Tolman, I don't think knew each other. Ironically or tragically, they both died in 1959. Kramer actually died in the field collecting fledgling rock doves for his research. Fell from a cliff in southern Italy, killed instantly, body collected from the river by his two sons who were accompanying him. But I said, by the time of his early death at the age of 49, he had established the entire field, he'd sent the whole field of animal behavior in the direction of orientation and navigation by establishing this, the pigeon as a model system. Across the world in Berkeley, of course, Tolman, we lost Tolman the same year, many decades older, but very similarly, both of these men in the same kind of period of time in the 40s had both come to the realization that also laboratory rats could not be explained simply as responding to stimuli, but were creating some kind of map-like representation of space. And that was also Kramer's great contribution, the map and compass theory, where he said that pigeons could not be simply responding to compasses. They had the sun compass, but they had to have something else. They had to have some kind of representation to be able to do the kinds of things that he was observing them do. And that was exactly Tolman's opinion and fight, and what he was also, both of them were laying this out in the same decade, actually, in the 40s and 50s. And so what's so exciting now is that the work that these two parallel tracks, and of course, and Tolman's specific theories of the cognitive map, led directly to this year's exciting announcement of the 2014 Nobel Prize in Medicine to Edvard Moser, our keynote speaker, Maybert Moser, and John O'Keefe, who will hear from Lynn Adele be talking about that, the work with John O'Keefe on the hippocampus of the cognitive map, and David Foster on place cells, and Edvard on everything else. But that work was a direct line from Tolman's work on rats running these mazes, believing that he was seeing something that could not be explained by the current theories of the time. So, and the importance, of course, of these maps is that it's not just the rat having the map, but of course it's also the map that we have, and subsequent work has shown that. But I'm an evolutionary biologist, and I'm also fascinated by the hippocampus because it is such a diverse, because it's actually such a conservative structure. It's found in all vertebrates. Here are half cross-sections of brains from various vertebrate groups: the mouse, the pigeon, the lizard, the frog, and the goldfish. And with the exception of the frog, all of these animals have been brought into the lab. They've had their hippocampal homologue lesioned, and it's been demonstrated in all of these animals, even though their brains look so different, that all of these animals, the hippocampus is working in the same way. It's actually creating a map of space. So the work of Tolman in starting this ball rolling is still picking up speed. We really don't know, and I think as you hear today, we really don't know how much more exciting it's going to get. It's really opened a Pandora's box. So I'm very interested in that, in how this is working in humans, but I'm fascinated in where this all came from. And that's my area of research, is asking how did the brain evolve? How does complex cognition evolve? How did the hippocampal map evolve? And so I'm interested in kind of unpacking the cognitive map into simpler and simpler maps that we can then look for these maps across other vertebrates and then see how, over evolutionary time, the simple map gets built up into a complex map. And so the simple map that I proposed with Francois Schenk in 2003 is called the bearing map, which is a very coarse resolution map that is built up from compasses alone, not from objects, from compasses like the shape of a body of water or the distant mountaintop, where gradients, such visual gradients, also olfactory, auditory, magnetic gradients, once orthogonalized, produce a Cartesian grid and can be used to locate yourself in space. And this is, the evidence for this is found in frogs and lizards and et cetera, in all vertebrates. But only when you get to the endotherms, the warm-blooded vertebrates like birds and mammals, you also get the ability to encode local small objects flexibly. So objects like the mushrooms, the rock, and the log sitting on the shore, if you were a bird or a mammal, you would also have encoded those discrete objects and also their topology in relationship to each other. And even if the shores of this lake was littered with rocks and mushrooms and such, because the topology would be different, you could encode different locations, which we called sketch maps, as unique topological arrangements. And what we proposed is that as a general model of how navigation evolved, you start with kind of the cold-blooded, simple coarse map, and then you add, with warm-bloodedness and the greater oxygen and energy consumption of the bird and mammal brain, you add this ability to do this topological encoding, and then also to combine the two so that now you've got the objects and recoded into the coordinate system of the large Cartesian grid, and that allows you then to shortcut between one object to another object because you've got this underlying grid structure. So that's that's what I've been working on, and working on the implications of this, particularly recently in olfaction, because it's a universal property that's used for navigation by all animals, including bacteria, and actually, but is used in, it's a very important cue for flying birds to navigate and use their cognitive map is actually olfaction. So I think this explains how this parallel map architecture can explain how individuals navigate and how their navigation is biased by their inclusion in their class of whether it's a species, an age, whether they're a lizard, a bird, a mammal, or even a woman or a man. Our model explains these kinds of differences. But speaking of humans, the other reason for today's meeting, obviously, is that I wanted a conference to highlight both Tolman's cognitive map work, legacy, and also a conference to highlight his humanity and courage. In his original cognitive map paper published in 1948, it was actually a Berkeley faculty lecture that was was given in March 1947, less than a year and a half after the conclusion of World War II. And at the end of this paper, he says over and over again, men are blinded by two violent motivations and two intense frustrations, into blind and unintelligent and in the end desperately dangerous hates of outsiders. This is obviously right after the war. And the expression of these, their displaced hates, ranges all the way from discrimination against minorities to world conflagrations. And then he concludes, we must in short subject our children and ourselves, as the kindly experimenter would his rats, to the optimal conditions of moderate motivation and of an absence of unnecessary frustrations, wherever we put them, and ourselves before that great God-given maze which is our human world. So, as this classic drawing shows, like lizards and mice, humans from different locations, geographically, culturally, and politically, see the world differently. Here's the view of the world from 6th Avenue, where China is a little blip. And you all know this classic New Yorker cover. And soon after giving that talk, Tolman found himself faced with exactly this problem at his own University of California. This morning's session focuses on insights into his life and his battle to protect the academic freedom of the university, and followed by this afternoon, where we return to the cognitive map. Our first speaker is Don Dewsbury, Professor Emeritus of the Department of Psychology, University of Florida. As a distinguished comparative psychologist and also a distinguished historian of psychology, Don could not be a more appropriate speaker for our conference. Don also happened to be an NSF postdoctoral fellow in our department in 1965, coming the year after completing his PhD at the University of Michigan, coming right at the events of the free speech movement, and the year before moving to the University of Florida, where he then spent his long and distinguished career. This career was recognized by scientific and historical societies because for Don's dual interests, for his research into reproductive behavior in mammals. He was a postdoc with Frank Beach here. His service and his really incredible efforts from 1988 to the present to document the history of psychology. And this led to exemplar, from the Animal Behavior Society giving him the Exemplar Award, the Exceptional Service Award, APA giving Lifetime Achievement Award, and also Lifetime Achievement Award from the Society for the History of Psychology. So please join me in welcoming Don Dewsbury.
Thanks, Lucia, although I can't live up to that, but there's my title. Personal note, it's nice to be back. I had a great year in Berkeley. I was here, it's hard to believe, but it was 49 years ago, and a lot has happened since then. I caught the aftermath of the free speech movement. It was just dying down, but I caught the anti-Vietnam protests, and those are two pictures that I took at the protest over on Telegraph there, the March to Oakland and so on. I'm basically going to talk a little bit about an introduction, biographical sketch, and say a little bit about his animal work, a little bit about social action, and then sum up. And I've got a lot to cover, so I hope you can hold questions if there are any to the end. This is Nancy Innes, died in 2004. And she was working on a book-length biography and spent a lot of time and effort on Tolman for more than a decade. Her advisor, John Stadden, said she thought she was attracted to Tolman because of his decent personality and work as one of the unsung heroes of cognitive psychology. She went to the International Congress in Beijing in 2004 and died suddenly of a brain hemorrhage. What that means is that, other than the personal loss, is that that biography never got finished. And we really need somebody to pick that up. It's not easy because her sister is kind of guarded of that work, at least she was last I saw. But it really does need doing. I think it's a shame we don't have a book-length biography of Tolman. Okay, overview, some key ideas, cognitive or purposive behaviorism, pioneer in the transition from muscle twitch behaviorism to cognitive approaches, humane and socially concerned, and a leader in the loyalty oath movement, somewhat what Lucia's just been talking about. Born in Newton, Massachusetts in 1886, a staunch New England family. Her mother was a Quaker, described as warm, loving, but in some areas puritanical. His father was in the founding class at MIT and a trustee. Had one prominent brother, who I'll mention in a minute, and a sister who was sort of removed from the family. I haven't been able to find anything about the sister, which, by the way, I haven't done the real archival research. I've only been working on this for a couple of months compared to Nancy. Nancy's the person who really should be doing this talk, but obviously can't. He married Catherine Drew in 1915. She was a Radcliffe Phi Beta Kappa, magna cum laude, and then Edward died in 1959. The brother followed the father, an old father, to MIT, became a very important mathematical physicist, and here's a picture he is with Einstein, and an important book on the theory of relativity of motion, known for the Tolman-Oppenheimer-Volkoff limit. You might run into Ruth Tolman. Ruth was not a Tolman by birth. She married Richard. She was an undergraduate here, studying in studies of criminal behavior, and worked with the OSS, and she became quite distinguished in and of herself. Chaired a subcommittee on women psychologists in World War II. Apparently, there's good evidence she had a long affair with J. Robert Oppenheimer. That's not just gossip. The first woman elected council of SPICE, World War II Veterans Association, president of Western Psychological, APA Board of Directors. So she was a consequential person. These are the children. On the left, obviously they were younger, the two daughters, Deborah Tolman Whitney and Mary Tolman Kent, and the son, Ted. Ted died last year at the age of 88. The picture on the right is of the two sisters. I took that at we had the memorial for Nancy Innes that Mac Runyon organized at a Chiron meeting up at the conference center. And I took that there where Deborah and Mary were visiting. Okay, I have these things about sources to remind me. If anybody wants to look sources, I can give them the reference. You don't need, but it's easiest to stick it in. Taken out of school for a brief time because of a heart disorder when he was in high school. Majored in electrochemistry at MIT, the family field. As a senior, he read William James, and I can't think of how many psychologists read William James and decided to go into psychology. He then took a course from Ralph Barton Perry, a comparative course with Robert Yerkes, courses with E.B. Holt, Herbert Langfeld, text by Titchener, and so on. So this is a current theme, is all these different things that are merged in Tolman's work. Harvard PhD in 1915 with Hugo Münsterberg, dissertation on memory and nonsense syllables. You don't associate him with that. Well, these are some of these influences. James, Robert Yerkes, John B. Watson. He found Watson's behaviorism very appealing and liked the behaviorism. The new realism of Perry and Holt trying to build purpose back into psychology, common theme in Tolman. One summer in graduate school, he went to Gießen to work with the Gestalt psychologists, especially Kafka. So you got all of these different influences working on Tolman. Instructor at Northwestern for 3 years, and he got fired for bad teaching. No, he wasn't a bad teacher. He was in anti-war activity, and obviously that's why, in 1917. He went to Berkeley here, or came to Berkeley here, stayed for 4 decades, declined a job offer at Harvard at one point. He went to Vienna for a while at the Socrel department at Harvard, so on and so forth. He soon began studying rats learning mazes. I thought that was my transition. Anyway, many honors. I won't list them all. National Academy of Sciences, honorary fellow British Psychological Society, the Kurt Lewin Award from SPICY, honorary degrees from here, Yale, and McGill, Distinguished Scientific Contribution Award from APA. Pretty good list. His early research here was in behavior genetics, and that's been an important part of this department over the years. He got 6 white rats from the anatomy department, and what he bred, the boys with the girls, and he tested them for maze learning ability, and he bred the male and female good learners, the male and female bad learners, to see what might be inherited. And what he found after the first generation, the F1, was there was a difference between them. Not huge, but a difference. He continued it for another generation, didn't work very well. Well, what he did was get a student named Robert Tryon. And you probably know the Tryon maze bright and maze dull animals. Tolman leveraged his Harvard job offer to get an assistantship for Tryon, who improved the study, went to a 17-unit T-maze, and got some nice results. This is the distribution after the 7th generation, and you can see there's almost no overlap between the offspring of the maze bright and maze dull maze bright males and females, and the maze dull male and female. It's a tongue twister. And the curve in the lower right here is the study carried out through 21 generations. And you see they spread out pretty well through, maybe 10 generations. There's a long tradition here of behavior genetics. I don't know if it still exists. I don't know if it is. But Jerry Hirsch did a PhD here. You can see his fruit fly study in the background. And Jerry McLaren was just leaving as I got here. So it's been here for a while. Okay, turning now to the science that Lucia introduced. In the 30s, there was a move toward neo-behaviorism, moving away from John Watson's behaviorism, which I'll get to, and getting a new approach, basically building in independent variables that intervening variables that you can't necessarily measure. This was a dominant force in psychology, which is hard to convey. I wasn't there, but the impression I got was this was the dominant issue of the time. That when you went to APA, you went to see what would go on with Clark Hull and Edward Tolman. I don't know if there is a dominant issue like that today. I'm not close enough to the current cognitive and other fields, but it's hard to convey how important this was. Look at the journals, look at the articles in the major journals. I guess I already said that. There was a great era of optimism. They could come up with a theory that would explain behavior. Isn't that wonderful? And you'll see the extent at which they were going to do that. Some regard it as a failure, but it trained an awful lot of good people. I don't know if we need this. Agreed with older forms of behaviorism that overt behavior should be the study rather than consciousness. You can do this speculation, and so on and so forth. There's Hull. He developed a hypothetico-deductive system. That is, you want a set of postulates and theorems and derive behavior from that. Mechanistic analysis of behavior. Treat the organism as a self-maintaining robot. That's kind of an interesting quote I got. I'm going to have to explore that some more. Reread Thorndike. The key was drive reduction and reinforcement. Okay? So the animal has a drive. It's food deprived or water deprived, whatever. And the goal is to reduce that. Anytime you reduce it, not the goal really, but anyway, anytime you reduce the drive, you get reinforcement, increasing the probability of behavior. Stimulus response conception of behavior in the mold of reflexes. Let's skip that. Here is a page, or 2 pages from Hull's 1952 book, I think. I can't read it over here. Anyway, you see over here postulates. Reaction potential, which is sort of the probability plus a couple other things that behavior occurs. SER equals 4 times the quantity 1 minus 10 to the minus, I can't read it, but it's 3 or 4 digits plus 0.46. That's the main dependent variable. That's how you explain the dependent variable. That's optimism. And here's this is the theorem. When a double restrictive reinforcement limit is placed, this was his theory. It sounds silly today, but it was important in dominant psychology in the context of its time. You always have to look at these things in the context of their time. It made a lot of sense, and he was very important. I don't want to make fun of it. I did. Okay, learning theory in his time. The cartoon at the top there. Bathroom, sure, it's just down the hall. Left jig, right another, left straight, so on and so forth. Just left, right, a stimulus response kind of a thing. I like the cartoon on the right. Stimulus response, don't you ever think? That conveys it. The dominant view was that learning gets stamped in a mechanical way. Tolman thought that rats behave with intelligence and with purpose. Totally different kind of an approach. Influenced, as I said, by Perry and Holt. He later preferred calling it operational behaviorism. 1932, he wrote a book called Purpose of Behavior in Animals and Men. That was really it wasn't the only, but the most significant work that he had. Common sense phenomenology, theoretical heuristic tactic. He wanted to sort of say, well, what would I do in the case of a rat? In my future work, he says, I intend to go ahead imagining if I were a rat, how would I behave? Curler called it cryptophenomenology. Mary, the daughter, wrote, and for my entire childhood, he was writing the book, Purpose of Behavior in Animals and Men. I still remember his pads of yellow paper covered with this small irregular scrawl. Tolman, and what I found this remarkable here is it's very similar to William James' idea of his principles of psychology. Possibly the most important book in the history of psychology, and how he couldn't stand to look at it. Well, Tolman says he was hoped that at the time the book was published, it might be used as a textbook. A few hardy individuals do that. I myself was never able to do it. It always turned my stomach. I just torn my vitals out and exposed them to the world. I was unable to look at those vitals without suffering either extreme shame or unseemly pride. Get that about your own work sometimes? Sometimes you're ashamed of it, and sometimes you think it's the best thing ever done. I do. I wanted to vomit at it, often felt so inclined. So much self-consciousness and affectation of style. However, I think that the book provided what was at the time a stimulating organization of empirical data. animal motivation and learning. And I'm going to focus on the data, the studies, which I think is what it really led to. I think I'll get there in a minute. Purpose of behaviorism, believing that there is a purpose to behavior, Stein-Gestalt theory, goal-directed behavior. With respect to Hull, to attempt to build a psychology on the analogy of closed mathematical or logical system seems to me a bad error. On stimuli, I found that on the internet the other night. We feel, however, that intervening brain processes are more complicated. Basically, the animal is selective. There's this whole array of stimuli bombarding it, but it's much more selective than people had thought. Okay, confirmation versus reinforcement. Reinforcement, behavior followed by reinforcement, was the be-all and the end-all originally of the behaviorists. Tolman says learning takes place not through primary reinforcement in the Hullian sense, but really through repeated confirming experiences, finding what restaurants lead to what foods, by what cost, and with what degree of gratification. Okay? You don't get reinforced because you make these lefts and rights, you go to a restaurant, you get good food. It's a much more complicated process of expectations and rewards. Behavior is goal-directed. Environmental supports, means, ends, relationships. Principle of least effort, prefer simple, easy solutions, as we all do. And it's molar and docile. Okay, I believe everything important in psychology, except perhaps building up a superego, can be investigated in essence through the continued experimental and theoretical analysis of the determinants of rat behavior at the choice point in a maze. So it's all about choice now, not about learning. Learning is important, but choice became the rats are much easier to work with than people. They don't go on binges the night before when there's a planned experiment. They don't kill each other off in wars. They don't invent engines of destruction. If they did, they would not be so inept to, and so on and so forth. They avoid politics, as he didn't, economics, papers on psychology. They're marvelous, pure, and delightful. I skipped over earlier, in an earlier slide, when he first started working with rats. He said, oh, they're terrible little creatures. They're crawly little things. And he changed his tune. Little maze humor there. None is perfectly directly relevant, but there's a lot of people publish cartoons on rats. It's a silly way to food, but you can't fight City Hall. These rats wish they were across the hall in the Masters and Johnson study, which wasn't with rats, but anyway. Tricky part is figuring out how to keep them from losing their will to live once they get to the center. And here you see rat figuring out a maze next to the guy on the train with the crossword puzzle. I'm trying to provide a little fun, but that was Tolman. It wasn't Hull. Hull was ill, fighting illness, trying to make this grand theory before he died. Tolman had fun, and I'll get to that later. He had a penchant for introducing neologisms and diagrams and so forth. I'm not going to say too much about the neologisms. I will show you some diagrams to represent that. But I think it's the experiments that really have been more influential than some of this. It changed over the years, but I'm trying to present an overall version. The basic diagram, you have an independent variables. These include stimuli, past training, maze pattern, age, so on and so forth. At the end, dependent variable, you have behavior. In between, you get these intervening variables. And there's a question of whether they were intervening variables in hypothetical constructs. I don't want to get into that. He didn't like the distinction, even though some other people did, McCorkadale and Meal and so on. Purpose, cognitive determinants, all these things that are happening inside the animal. And that's what the behaviorists didn't want to do. He talks about all these different things going on. and brings it all into relief. Here's another version that fills in a little more. Particularly in the middle there, you get his needs system, belief value matrix, immediate behavior space, restructured space. All of these have got arrows back and forth and interacting and so on and so forth. There's so many of them that... Here's another major, the major independent variables, behavior space, distance, direction, as perceived by the animal, so on and so forth. A belief value matrix, learned categorizations and differentiations concerning environmental objects. Here it's the rat that gets a little more developed, and you've got the personality structure and the inner life space of the rat with all these interactive forces that are going to determine whether it turns left or right in a maze. This characterizes that part. I don't think that this part of Tolman was what lived on. It was his influence and approach in other ways. Okay, now I want to talk about the experiments, which I think were the heart of Tolman. He worked on expectancies, contrast effects, learning performance distinction, latent learning, stimulus searching, place response learning, and then there's something called cognitive maps, which you might be familiar by now. Anyway, Tolman believed that animals form expectancies. I said that. Anticipations of outcomes. He called them means-end relations. Signed gestalt expectations. Confirming rather than reinforcing. Otto Leaf Tinklepaw was a student here. In 1928, he published a study where he trained a monkey to get food under a cup. Okay? The food for some animals was a banana, for some it was lettuce. Great. They both learned perfectly well, although I don't know if there was a difference in rate. Now, what happens if a monkey is trained with a banana and gets lettuce instead? The picture doesn't come from that work, but if trained with a banana and lettuce was substituted, she looks at the lettuce, but unless very hungry, doesn't touch it. She looks around the cup and behind the board. She stands up, looks under and around her. She picks up the cup, examines it thoroughly in and out. She has on occasion turned toward observers present in the room and shrieked at them in apparent anger. Anybody see that in humans at all? Okay, expectancies in maze learning. Basically, it's a similar study in maze learning in rats, where you can reward the rat, I prefer reward, for with either kind of two different alternative goal objects, in this case bran versus sunflower seeds, and their behavior is disrupted when you change it, when you change the reward. So they are having an expectancy for Tolman. And when you change that, it's not just learning stimulus response, it's expectancies. Not done in his lab, the Crespi effect, which some of you may be familiar with. Here you're training rats for two different reward sizes. And they learn differently. The ones that get a large reward have a better performance rate, not learning, performance, and the other ones have a slow run. Now, you flip them around. The ones who are getting large get the small, the ones who are small getting the large. And you keep a control group, of course, going. And what happens is, the guys that were getting the low reward, all of a sudden they perform better. The ones that were getting a higher reward have a depression effect. They go below where they would be if they were trained with that level of reward all the time. David Kresh here studied hypotheses in a maze here, 4-compartment maze. He could open and close either door. And he changed it every trial. Well, I couldn't possibly learn that. So what they did was they formed hypotheses. For a while, they might go left everything. They might go left, right, and these persisted for a while. They seemed to form these expectancies, even though they really weren't rewarded. Pardon this cartoon. It's taken out of an old newspaper, but I think it's really hits the spot. This is the learning performance distinction, which I want to talk about. It says he knows a lot more tricks than he'll ever do. And that's the essence of this distinction. Traditionally, psychologists inferred learning from performance. The animal performs something, it learned it, and it leaves it there. Tolman showed that learning might have occurred even though there's no overt performance. Hull had to then modify his theory, which he did in 1952, to make this distinction. Tolman credited Lashley and his student Blodgett with first making this distinction. An example is latent learning. Okay, with latent learning, the results in the next slide really show it as well as anything, but there's 3 groups of rats learning a maze. Okay? The first group is, the 3 groups are all food deprived. Some get food or reward, others don't. Now the ones here that are not getting any food, the 2 groups at the top, don't learn very well. They don't perform very well. The ones that are getting food reward, hey, they do nicely. They do, the time in seconds to run through the maze decreases. Now you begin to give one of the 2 groups that's not getting any reward, you give them a reward. What happens is that they suddenly perform better. And the key word there is suddenly. They're not performing, they're not improving at the rate that the learning curve did. They're suddenly showing an improvement in performance. So something was going on there the whole time, which was not being translated into behavior. This is another one that I'm a little nervous about because I don't think it was ever published, and I would like to explore further. But it does tie a little bit to some of the later work by some people like John Garcia, who I'll get to briefly. Rats are in a chamber, and they're fed food from a food cup, or I think in this case the illustration is water from a water spout. So they learn to do that. They get shocked. One trial learning, they stop. Okay. Now what Hudson then did was make the light disappear, make the pattern, the stripe pattern, disappear as soon as the shock is there. Okay? So the animal drinks and the pattern disappears. They go ahead and drink. So what he argued was it's the consequence that's responsible for the change in behavior. A bit like, what was that? Okay? They go and they drink. This behavior that occurs before the shock, it's more like, what happened after that? What was that? And I don't know where that stands. I'd like to look into that more. VTE, vicarious trial and error, a major concept in Tolman. Adapted it from Carl Munziger. And these are basically behaviors. You're standing in a corner, you don't know which way to go. You stand there and look back and forth. Oh, I think I'll go this way. That's vicarious trial and error. It's trial and error. It's not just moving. It's vicarious, VTE. And these are various apparatus, a couple apparatus in which he studied this, and a couple of cartoon versions. You would think that there would be more VTEing in a complex discrimination. When he did the work, it turned out to be a little more complicated than that. In this particular study, they're learning the difference between a white card and either light gray, medium, or black. The black was an easy one. They learned that quickly. The medium gray, a little more difficult. The light one was so light, I guess they didn't learn it. Do a lot of visual studies with not very good visual animals, but anyway. The average number of VTEs, the point that Tolman made was it seems to reflect where they are in the learning process. If you look at the group over here, the easy discrimination black, it peaks right here in the middle. And what he argued was that that's the point where the rat has, to anthropomorphize, sort of figured out what the problem's all about. Now he's attending to the stimuli. Too early, he doesn't know enough to respond or to attend to that issue. Later, he doesn't need to. And that you get that. Those are not clean data, but anyway. Okay, the schematic sow bug. This is his model for factors affecting behavior. Behavior at a choice point is influenced by opposing factors, and these can produce the VTEs, influenced by Lewin and Gestalt psychology. One gets the impression that Hull in Bad Health tried to make his mathematical model complex. Tolman sort of had fun. You got all these things. You got orientation vectors and progressive transitions, receptor organs, so on and so forth. All these affecting which way this sow bug is going to go. And he's building in a lot of his independent variables to try to make sense out of behavior. Obviously, an affinity to Kurt Lewin. His Lewin eggs here. Lewin did a bunch of these. In fact, Tolman in 1949 got the Kurt Lewin Award. Lewin's basic premise that every object exists in a field of forces that move to change it. And he had ideas on expectations, feelings, attitudes, so on and so forth. And Tolman, I think, was very strongly influenced by these. Oh, here's some other diagrams. Tolman loved these diagrams in there. A couple of different ones on learning, early and late in learning. I can't go decipher all of this. So on and so forth. Hate was one of his, a very interesting topic for somebody who seemed incapable of hate. Heredity, age, training, and endocrine effects, and how they affected behavior. Donald Campbell wrote, many of us still expect out of cybernetics, servo systems, engineering, automation theory, and artificial intelligence to come to the next comprehensive behavior theory. Tolman's theory, both purposive and behavioristic, is the theory of the 1930s, closest to such a development. He gives him credit for developing this field theory in a way that became later relevant. His article on cognitive rats and men, as Lucia mentioned, was a faculty research paper here. And this is where he begins to get the idea of cognitive maps fully developed. Behavior is purposive, goal-directed, cognitive, so on and so forth. According to Tolman, rat forms a mental representation. I think you know what this is, and so on. And you get into the place versus response learning in some of this research. He proposed that some clinical problems, such as regression, fixation, and displaced aggression, can be due to narrowing of the cognitive maps. That's kind of an interesting idea, I think. Well, the experiments are, I think, kind of interesting. In this one over here, if I knew how to walk over, I would have reversed these. The rats explore this maze. Okay, pretty simple maze. No reward, so on and so forth. And not deprived. Now you make it a task where they're food deprived and they have to find the food in the food box up at the top. Well, what do rats do? Well, they do the obvious thing. They go the red route. That's the quickest way to get to the food. Okay, now you introduce a block at block A here. Well, you can't go the red route anymore, so what do? You go the green route. And they do it quickly. It's not that they have to learn a new task. They adapt very quickly. Then you put a block at B. Well, now neither of those works, so they have to take the blue route. And again, they're good at learning, they're doing this very quickly. So they must have been learning something about that apparatus. Here's another one on place versus response learning. You got two groups of rats and the maze at the top. You can start either from S1 at the bottom or S2 at the top, half the time from each start place. Now, one group is the response learning group. They always have to make a right turn. So if they start from the bottom here, they have to go to the right to get food. Start from the top, they have to go to the right to get food, different location. The place learners always have to go to the same place. The food is on the same side. And he argued that this shows, as you can see from the data there, that the place learners do better than the response learners. And this was an issue between Tolman and Hull. And Tolman essentially won on this particular issue. In another one, you train rats to go left in a maze to get food. So they have to go through this, I don't know why I use these a lot of times, but you go through this center area, and it goes up, and then to the left, right, so on, and it gets to the food. Now, you take an animal's train, put them in the apparatus, but there's this whole fan of all these possible places to go. Where does it go? Well, it's been trained to go forward to get food. Do they do that? No. What they do is go over this way. I said, they know the food's over there. They're not going to go straight, as they've been trained to do. When you block here, you block the center area, and they go directly, or not perfectly, but a lot better than chance. This is one from Ritchie. Rats could be trained either left or right. I don't know if I want to get into the details of this. What you then do is flip the maze from this way to that way. Over here you can see in dotted lines at the top the way the maze was originally, and then down at the bottom. And what basically the rats learn to do is go to the place where the food is. And in all these studies, I think all these, they're extra maze cues. You know, there's a sink over here, there's a door over there, and these are all very helpful. I think it was when I was here, I did one study where, maybe it was in Michigan, where we put cheesecloth all around to get rid of the extra maze cues and see how that worked. I don't even remember the result of that, frankly. Crutchfield did a study where rats were trained to go, in one group they had this maze here, this wasn't here, it was blocked. They had to train to go this way or that way to get food. And one at the top, they just had to go in a Y rather than this structure. And this is from another paper, but a T. What happened then when they open up this straight ahead one is that these guys have a harder time learning to go straight because they have been making this turn rather than these guys who are making a little turn. And that can be interpreted within the schematic sow bug with all of these different forces, field forces, influencing the behavior. I don't want to get into this, but I have the slide there anyway. I just want to make one point here. There has been a controversy in honeybee orientation. And it's been going on for a while, and there's a paper in, I don't have the date there, about 1990s, where the authors say the cognitive map hypothesis is now dead for honeybees. Then there's an article in the PNAS this year which concludes, further strengthening the now extensive evidence of a metric cognitive map in bees. Is there a cognitive map in bees? I have no idea, but it is an issue in honeybees, and the brains are very different. I don't think they would have place in grid cells, but maybe. But I can't conceive that you would have a similar. And also in the, as Lucia mentioned, the map and compass idea in birds, which again, there's similarities. I don't know. It'd be interesting to explore. Okay. Tolman wrote a bunch of different papers. A collection of his articles in this 1951 book, Behavior and Psychological Man. And you see a little bit of the range he had. Can instincts be given up in psychology? Behavioristic account of the emotions. Behavioristic theory of ideas. A behaviorist definition of consciousness. Psychology versus immediate experience. Stimulus expectancy need cathexis psychology. And includes the cognitive maps paper and the choice point paper and so on. Tolman's, this is a quote from Jack Hilgard, Tolman's Catholicity, how do you pronounce that? Catholicity? Whatever. He was very Catholic, meaning general. And his friendliness to new ideas prevented him from developing a tight or elegant system, even though he made suggestions as to what a system would be like. Hull's theory had more immediate impact as he trained more students who went out and followed it. Tolman developed a model closer to modern cognitive approaches. Don't try to get through this slide. Basically, Donald Campbell argued that Hull was more influential because he had more students who went out and followed up. They went from Yale, and particularly Iowa, who Kenny Spence was, and they moved out from there, and they did the same kind of work. Tolman students didn't do that as much. They moved out, they loved Tolman, but they went their own way much more. And I wonder if that's a Berkeley kind of characteristic. I know it was the case when I was here with Frank Beach and some of the other labs, Newark Rutgers, for example. I think the Beach people felt a little more free because Beach was that way. He didn't take his theories, we worked too seriously. He took it very seriously if he thought he said some stupid things, given what he could have known at the time he wrote it. But if he came back and said, no, we now know more, that's fine. That's what we want to do. That's very much a Tolman kind of an attitude. He had a bunch of students. The Tolman seminar was an ongoing seminar where students and Tolman exchanged ideas readily. I haven't found a complete list of Tolman students. It probably exists over in the archive somewhere, but I haven't found it. I just haven't been able, I've only been working on this a couple months. Benbow Ritchie is one who was here when I was here. He's in the right of this Nebraska Symposium panel. Xingyang Kuo became a very important comparative psychologist, came from China and did a lot of work on development, career cut short by political activity in China, as you might gather. Richard Crutchfield was here for a while. John Garcia, the Garcia effect, one trial learning, taste avoidance learning. Charles Honzik and Otto Tinkelpaw. Henry Gleitman, prominent generalist and textbook author. And Jim McGaw, who did a lot of one trial learning and became very important in many ways. That's one of my favorite pictures. There's several favorites in here. This is Tolman, Hull, and Lewin. Lewin on the left. And Hull and Tolman there sticking their tongues out at each other. Wonderful picture. You can see Hull with a cane. He was failing at this point. Sort of transitioning a little bit, he wrote a book in 1942 called Drives Toward War. He was socially concerned throughout his life. He was a pacifist, tried to explain reasons for human tendencies to fight wars, included some Freudian thinking, and suggested that social controls were necessary for human society. The ever-present diagrams, we've got some Freudian concepts in there. I won't go through all of them. I enjoy certain idiosyncrasies, which also determine my attitude toward war. I'm physically unaggressive and was brought up by a Quaker mother. I was the youngest of the family and decidedly overprotected. Fighting was taboo. My aggressions were driven underground in attacks of indigestion, compulsive ambition, and probably also my dislike of war itself. Whenever the Western world had been threatened or had felt itself threatened by outside groups, then the masters of the gospel, like the communicants, have rushed to preach war and vengeance, not peace and forgiveness. The new economic order will, I believe, consist in some sort of compromise between private initiative, self-assertion, which was the virtue of pure capitalism, and the purely collective techniques, which would be the virtue of a pure communism. Russia today, in 1942, seems to be approaching such a system. I think these quotes are interesting in terms of what happened later. A world federation or superstate, or whatever we may want to call it, must command all our allegiances more strongly than our national states now do. Just as now I am more loyal to the United States than I am to California, So in the future, I must be more loyal to this World Federation than I am to the United States. Okay? Later, we get to a loyalty oath. Yeah, it's broader social concerns. Again, we get the diagrams. He became even more concerned with issues. If our need as human beings for a liberal society be passionate enough, if our demands for freedom, for fair play, for honesty, for open minds, and for simple human decency really be overwhelming, and basically I believe they are, then whatever our fears and distorting mechanisms, we men will continue to seek truth. Our liberal schools and colleges will survive in spite of recurring attacks upon them. They shall neither be communized nor Nazified. For I assert that we, the people of all of us, intellectuals and non-intellectuals alike, still want the truth and nothing but the truth. Biological science of structure is described on the left, personality structure on the right. He had a diagram for everything. I don't want to say too much about the loyalty oath issue because Seth is going to talk about that. But you can't talk about Tolman without talking about the loyalty oath. 1949, the Board of Regents, and there's a wonderful set of pictures in Life magazine where I took these from. They decided that faculty must sign the loyalty oath, that they were not members of the Communist Party. He'll give more detail on that. Tolman was the leader of the opposition. He was fired, but then won and was reinstated. That part I think is generally known. In the end, it was more of a power struggle than a struggle of principle. Okay, he lost initially, but won in the long run. They fired him, but then he came back and got the honorary degree. There's a building in Berkeley called Tolman Hall, opened in 1962. Apparently it won't last too much longer, and you may be familiar with that building. The dedication is here on the right. The second from the left is Catherine Drew Tolman, which is the only other picture I have found of his wife. Edward, of course, was dead by this time, with Clark Kerr and Chancellor Edward Strong and E.R. Hilgard, who gave the speech. I imagine that behind the speaker is Pat Brown, but I don't know. Okay, Nancy Innes, in an article in Minerva, the journal on Tolman, and it's kind of interesting, we'll be going over the Minerva Foundation, which seems to have no connection with it, as far as I know. I have a bunch of quotations about Tolman I think give the characteristics of what he was like. With respect to the loyalty oath, which is where this one was, the fact that the alliance of both liberal and conservative non-signers of the Group for Academic Freedom remains strong and effective may be attributed to the personal qualities of their leader, Edward Tolman. Tolman, a man in his early 60s at the time of controversy about the oath, was highly respected by his colleagues as a calm, dignified, self-controlled person, but not without warmth and humor. His leadership gave respectability to those who opposed the oath. Although he received a great deal of pressure to sign from colleagues who believed the university was being damaged by his stand, Tolman showed them no animosity. Thus, it's easy to understand why, only a few years after the controversy had ended, Edward Tolman was awarded the honorary degree by the University of California. And then on 16 March 1963, the new building was named in his honor. It was a victory for those who believe in the value of academic freedom as indispensable from the fruitful working of the modern university as the central site of advancement of learning. The victory would never have been possible if Edward Tolman and a small circle of colleagues had not been unswerving in their intention to hold fast. Without his tenacious courage, can't go too fast, Judge Peake would not have had the occasion to remind the Board of Regents that the Constitution and state of California had instituted academic freedom in the very foundations of the university. Well, the Group for Academic Freedom is the one that it was formed in response to this loyalty oath threat. It had no formal status of any sort, really, but they gave him an honorary degree anyway. The Group for Academic Freedom, by the authority of the liberty-loving people given to us in sacred trust of our fight at the University of California, in recognition of his meritorious achievements, has conferred the degree of academic freedom upon Edward C. Tolman, chairman of the group. Genius in human relationships, lover of the good and the true, defender of human rights, kindest of men, has been a tower of strength and never failing inspiration. My witness thereof is inscribed by the signatures of all, given at Berkeley this 25th day of August, the year of our Lord, 1950, of this group, the first. That was the date of the ultimatum from the Board of Regents that everybody signed. Tolman, may you nor we ever seek to hold these propositions, save in a somewhat amused, somewhat skeptical, and wholly adventure-seeking and pragmatic attitude. I don't think I read that well. If we're to advance, we must first understand and then attempt to incorporate into our own the perspectives of our sister sciences, not merely those sciences pertaining to physiology, but also even more those that pertain to social living. Sane and sensible men, not an imperialist, never that one position, one point of view could be all-encompassing. Able to accept, this is from Henry Gleitman, one of his former students, able to accept concepts from such diverse sources as American functionalism, Gestalt psychology, Lewinian field theory, psychoanalysis, and Brunswickian probability theory. He's merging together all of these different influences. The most unrigid psychological thinker I've ever met, wary of too much methodology, reliance on methodology. His personal qualities allowed him to be more willing to hedge, to wonder, to be puzzled, to be more open to the world than other people. I think you get the idea. Now here's some trivia from the book written by his daughter, Mary Tolman Kent. Things you don't always associate with him. He had a horse named Cookie. They kept near his home over in La Loma. La Loma, yeah. They rode the horse through the hills, which is now where Lawrence Berkeley Laboratory, Hall of Science, Botanical Garden, all those things now stand. That was basically his horse riding area. In the 15 years or so before retirement, he bought a ranch in Lake County. He always wanted to be a rancher. He was a compulsive coffee drinker and smoker. Family had puritanical streak, New England Unitarianism. He drank, but not much. He was never seen drunk. He was a great dancer, though he was told tone deaf. He bought some Coca-Cola stock for his son, appreciated to over $1 million, and bought land for him. Ted became a rancher and a forest firefighter. You know about that out here. Inferiority complex, made jokes about himself in relation to his older brother. One of his parlor tricks was a scarf dance a la Isadora Duncan, who had these, he was a famous dancer of the time, and these sort of sexy scarf dances. Traditionally, they invited the young faculty and graduate students and wives to have dinner there, followed by a baseball game in a nearby field. This is the man, try to fill out what he was like a little. Now, I'm a little worried about this because there's a difference between ceremonial history and critical history. Ceremonial history is a no-go among historians. You don't do that because these are people. These all have their flaws. And sometimes this comes into trashing the subject. The problem with Tolman, I haven't done enough research, I can't find these. I mean, he had weaknesses. He wasn't perfect. I guess he didn't walk on water. Sometimes it looks like he did. But I'm a little nervous about giving a ceremonial history, which is what it is, because I really don't know where the rest of it is. Okay, key contributions, learning performance distinction, latent learning, cognitive map, response learners versus place learners, expectancy theory, intervening variables, I shouldn't have in there, purpose of behavior and social action. Okay, I think just two more, maybe three more quotes from Tolman. I do want to point out that such experiments were fun to do. Although they took a long time, and although the results, when we got them, persisted in being slight, confused, and somewhat sleazy, But whether such experiments or such models will in the end have any world-shattering importance seems doubtful. In short, we've had a delightful time and absolutely no dull moments. And Nancy's book was tentatively entitled Having Fun. I've liked to think about psychology in ways that have proved congenial to me. Since all the sciences, and especially psychology, are still immersed in such tremendous realms of uncertain and the unknown, the best any individual scientist, especially any psychologist, can do is follow his own gleam and his own bent, however inadequate they may be, in fact. I suppose this actually is what we all do. In the end, the only sure criterion is to have fun. And I have had fun. This is my favorite picture. I have a lot of favorite pictures from the Life article. You know this spot on campus, I imagine. He closed his presidential address in 1937 at APA, the Choice Point address, with a brief verse from Alexander Michaeljohn that Michaeljohn had inscribed in Tolman's, in a book that he had given Tolman. To my ratiocinations, I knew I'd mess that one up. I hope you will be kind as you follow up the wanderings of my amazed mind. The end.
I've always wondered, most of his most iconic experiments, or those who are traced to him, are published mostly with his students, and his name is not sometimes on a lot of them. Was that systematic? I've never heard anybody mention it, but it just seems to me that as you present it, and I've heard it before, his iconic experience. What was the interplay between his students and himself, and how did that come about?
I don't know, but there's a real difference, I think, among the way principal investigators interact with their students when they publish papers. Some of them want to be the first author on everything, and some don't, and they want to give full credit to the student if they possibly can. Some, of course, mix it. In theory, it depends on how much of the contribution was made by the professor or the student. There's what's the name I'm seeking for? The effect, Matthew effect. If it's a paper that's published primarily by a well-known person, they associate, even if it's a fourth author, it gets associated as that person's work. If it's first author, it's even more so, especially in these days of all kinds of frequency counts. I don't know. The answer is I don't know. But when I was here with Frank Beach, he was that way too. The students got credit, and he often didn't want to have his name appear because it would be associated as Beach's work, not the student's work. And very often, he might be listed as a later author. So I think it just depends on, the amount of contribution that the people did. I mean, Tolman and Hanzik is a classic paper. Tolman was the first author. But it depends on how much they actually contributed, at least in the mind of the senior person, and what their policy was in terms of these kinds of factors. But it's an interesting question. And there's been a lot written about this issue. Yeah?
Could you comment on the connection of Tolman and B.F. Skinner in connection with, like Skinner, Can you comment on the connection of Tolman and B.F. Skinner? In particular, Skinner felt that his research in psychology had implications for society, for how to make society work better. Did Tolman have any such?
They both did. That's a tough one. I don't know much about the interactions between Tolman and Skinner.
Not necessarily interactions, but did Tolman really feel that his ideas could change society?
I think so, yeah. Everything important in psychology, except for the few things he mentioned, can be studied at the behavior of rats at a choice point or in a maze. And the diagrams where he includes human behavior aren't very much different from the diagrams where he diagrams just rat behavior. I think he believed that. And I don't think he was the kind of person who could compartmentalize the way you're suggesting. I think he was much more of a gentleman, yeah. Yeah, Mac? Oh, go ahead.
Just wondering about to what extent Tolman expressed interests in the neuroscience that was going on, like Lashley and later Hebb, or whether he explicitly stayed away from it like many of the other behaviorists.
I can't think of a really good example of where he really gets into real hard physiology. With time, I might be able to think of something, but I don't think that's where his head was. And yeah.
I can speak. Tolman tried very hard.
Herb Zucker, yeah.
I'd like to mention that Tolman tried very hard to recruit Hebb to come to this psychology
Did he? I
department.
didn't know
He
that.
did. If Steve Glickman were here, he could tell you about that in great detail. He's done research on that.
When would that have been? Yeah.
It would have been in the early 50s, I think, after
Okay.
Hebb published The Organization of Behavior. And you'll notice that throughout your entire talk, when he was mentioning different factors that were involved, there was never a mention of the nervous system, but he did mention the endocrine system.
Right. Said by somebody who really loves endocrinology.
So was Tolman, I mean, was quite impressive about how he had such connections to people studying personality, social psychology, clinical psychology. Was that unusual? Was he exceptional that way, or was that kind of the standard within the field at the time?
Skinner. Hull didn't do much of that in terms of relating to personality. The Gestaltists certainly did. I take that back. Hull didn't do much himself, but his students did a lot. And Neil Miller and Miller, Dollard, Sears, I can't remember the rest of the name of that book that they all published together. They all did a lot. Maurer, I'm missing a name there. Dollard, Miller. Anyway, I knew that at one point. But I think, yeah, his students did. I think a lot of people did. I don't think it was that uncommon. Of course, there were some people who just stay in the lab and don't care about anything else. I mean, it's true everywhere. Mac was asking one in the back, but yeah.
You mentioned a lot about how Hull was quite ill at the end and was trying to wrap up his work. What was the end of Tolman's life like intellectually, and what was on, did he go out with a whimper or a bang?
Well, my excuse is going to have to be I've only been working on this a couple of months. I'm not a Tolman. I'm trying to become a Tolman expert, I guess. The last couple of years, I don't know. Somebody, Al might know, yeah.
He had a bad heart, and he suffered from cardiac insufficiency, and he became progressively weaker and died. And I think it's about as simple as that. In the last year or so of his life, he was almost totally inactive.
Yeah.
Yeah.
He had a good heart, but he had a bad heart.
Yeah, that's right.
We found a manuscript of his a couple of weeks ago in the IPAR archives, and we shared it with Mac and Lucy. It was I think it might have been for a course. It was sold by the Student Union, and it was called The Wants of Men. Have you by chance, it was written in 1948. No. Have you had we can't find any, we just started, but we've so far found no mention of it anywhere.
He wrote a bunch of papers during that period about human events and human affairs, and it probably fits in there. Drives Toward War was 1942. So it's something he was thinking about a lot. And then, get into the free speech movement, well, not the free speech, the academic freedom movement, and later free speech, and then again when I was here it was the Vietnam.
Just one quote you put on the board caught my attention. He said about using his book, he said it made him want to vomit. Go back and read it. And that's kind of unusual. I mean, people can be self-critical, which I think he was in a way, but that's sort of an unusually strong response.
Right.
And then,
okay. It made him vomit.
It made him feel
I misheard.
like
I thought you said you wanted Obama to go back and read the book.
No.
That's selective. Okay, I'm sorry. But James, after Principles, wrote something. It's nothing but a tumefied, bloating thing that proves nothing except that WJ is an incompetent. There's a whole long quote there about the Principles.
Right, and my question is that Tolman seemed to be unusually like self-deprecating in a way, sort of making fun of sort of the importance of what he was doing. And I was wondering, do you have any thoughts about?
I think that happened early when he had a brother who must have dominated him. He was such a prominent physicist. And I think it was at Caltech, if I recall correctly. Right. I think that's the heart of it, and it's a simplistic explanation from a rat psychologist trying to interpret humans, but I think that certainly was part of it. I'd like to find out more about his older sister. I haven't been able to find anything. But then Nancy might have known it, but we don't have her anymore. We needed somebody to write the book-length biography.
On that ambitious note, I think, thank you very much, and